of the coffee makers sold in an appliance store, 6% have either a faulty switch or a defective cord, 1.4% have a faulty switch, and 0.6% have both defects. This just feels like a Venn diagram problem. So I'll use the Venn diagram to set this thing up. I'll do this in a second way as well. So faulty switch or defective cord. So let's see. 0.6 have both defects. We always start with that intersection, right? So 0.6. This is in percentage. So 0.6% have both defects. 1.4 have a faulty switch. So here, this entire circle represents that 1.4%, including that 0.6 that have both defects. So if I have 1.4% minus the 0.6 that's already in the circle, that should be 8/10 that only have a faulty switch. And 6% have either a faulty switch or a defective cord. Now that's 6% that have either a faulty switch or a defective cord. That's all these regions added together. Remember, or, when we're talking probability, is either or both. So the sum of all three regions here should be 6%. So if this is 1.4, we'll see 0.8 plus 0.6. If this is 1.4, 6.0 minus that 1.4, this 1.4 here, is going to give me 4.6. That's the probability that we just have a defective cord. So the probability that a coffee maker has a defective cord, we can't just use 4.6 now because these are people who only have a defective cord. But these 0.6 also have a defective cord, but they just have a faulty switch as well. So if we're adding everybody that has a defective cord, including those that have both, that's 4.6% plus 0.6%. So the probability of having a defective cord is 5.2%. Now you can also do this problem using the inclusion-exclusion principle, and I'll show that down here. So that's the probability of A or B, that formula there. In this case, it'll be the probability of I use F for faulty, or defective would be the probability of a faulty switch plus the probability of a defective cord, minus the probability that you have both a faulty switch and a defective cord. So we have the first probability. We have the probability of a faulty switch or a defective cord. That's 6.0%. And the probability of a faulty switch, we have that as well. That's 1.4%. Plus the probability of a defective cord. We do not know that. That's what we're trying to find. Minus the probability that they have both, which is 0.6%. So let's see if we can whittle this down a bit. So we've got 6.0% equals 1.4 minus 0.6. That's our 0.8% plus the probability of B. That's this number here that we got. And if we subtract that 0.8 from both sides of this equation, we end up with our 5.2%, which is the probability of a defective cord, which is exactly what we found here. And that is our answer. Both ways. You can do a Venn diagram to get this, or you can use that inclusion-exclusion principle to get that as well.